Helps if you unmute the microphone, Mr. YouTuber. Hello, and welcome to another online live Onshape design session. This is a series where I go through and I sort of walk through my thought process as a mechanical designer and what I'm thinking of when I'm designing a part in 3D CAD. In this case, we've been working through a redesign of the Stinger robot. This is a little demonstration robot for career fairs and things that students of mine built for their capstone last year. Take it around to the career fairs, middle school students, high school students, give them an idea of what we do in a mechatronics program. The original robot, I keep saying over and over again, is beautiful. The students did a great job. The thing that I don't think any of us anticipated was just quite how violent's a good word, that visitors to those types of events can be on the equipment that we bring for demonstrations. So yeah, I needed to come up with a version that was a little more robust, a little more easily repairable, hopefully, if something breaks. And that's sort of what we've been working through. So let's dive right into Onshape. And last year, wow. Fresh cup of coffee, by the way. I am thoroughly caffeinated for this, so when I misspeak, it's especially egregious. What I was going to say is sort of last week, the plan was to finish, pretty it up. The finishing plan is to just sort of fillet some rough edges, make the thing a little more streamlined, and sort of go from there, right? Export maybe an STL file, maybe a step file, and take it and print. But then, about 3/4 of the way through the stream, I realized that I forgot that we were resting on two wheels and didn't have the other sort of support feet that we needed. So that's where these skeletonized pyramids came from. Those will be our extra feet. And sort of toward the end and in the intervening week, it started to bug me more and more. Just how small these sort of leading edges are, this leading support. I don't think it's quite perfectly square, but it's effectively an eighth of an inch square, eighth of an inch on a side. And that's really small. Like, I am really nervous about the forces that thing's going to have to eat. These are pyramid, so there is a slight angle, but if we look at this from sort of this angle, hopefully it illustrates my concern. So this isn't, it isn't a pyramid, it is at an angle, it's not a super high angle, to give us a lot of added support in sort of this direction. So if, say, the front leg here were to snag on carpet or hit a grout line and tile on the floor or something to that effect, this eighth inch on a side support is going to be in under a lot of tension. And while I don't have that quantified, like I could, I suppose, load it up in a stress analysis and actually see, but that's going to take a heck of an assumption about how much force is actually being applied. I could get the stress and maybe some deformation and stuff and see if it would fail. But there's a lot of guesswork as far as what actual loading conditions it would be under. All I can say is sort of intuitively at this point, it makes me kind of nervous just leaving it out there. So, my sort of promise throughout this whole series has been not to touch this thing in the intervening days, between episodes. I sort of broke that a little bit. I didn't make any changes permanently. I did play with some stuff and deleted it all to see what I liked to sort of shore that up. And here, live on stream, I'm going to mess with my audio because for some reason I turned on monitoring and I can hear myself in my own headphones on a delay, which is really annoying. And it's leading me to what I feel like is talking really slow. So just 1 minute while live, I try to remember where that setting was. Audio would seem correct, but that's not quite right. Is it under the settings here? Properties. Monitor, there we go. Off. Awesome. Cool, I can still see my levels. I'm not hearing myself on a delay in my ears anymore. Good, awesome. Let's get back to Onshape. Cool. So yeah, I'm really nervous about how small this thing is, especially, like I said, if it snags a carpet, snags a ground line, something, there's going to be an awful lot of force on not a lot of plastic. There are some things I could probably do, like fillet this pretty heavily, but no matter what I do, I'm going to end up with a really thin piece of plastic there. So what I was playing with, and I'm not sure I like the solutions. I'm going to show what I was playing with and sort of the idea I was toying with, and that's basically to add sort of a plastic bridge between this face here and like this lower portion of the motor mount, either there or even back to here, just like a plastic bridge, just to give us that extra support in the key direction that this front sort of leg would see, this front post, whatever we want to call it, would see the most force. And I'll demonstrate sort of the way I was looking at it, the way I would do it. Now, this won't be entirely accurate on this face. I would have to add more plastic because if we look at the assembly, there's not a lot of room under here, under this PCB, to get more plastic underneath. But I will just sort of demonstrate the idea of what I was thinking about because it's fairly quick to do. I need a sketch, and I'm just gonna lay it out real quick. And I don't think. Again, I'm working off of sort of my gut feeling is this thing's way too thin. I just need material somewhere to eat some extra force. That's really all I'm thinking about. But I was thinking something along the lines of, so a rectangle there, and again, this is just, again, along the lines of, it's not a true, it wasn't a fully fleshed out idea. I need a sketch on this surface, and basically what I'm going to end up doing is I'm going to do a loft between them. I was thinking to do a sweep, and I was actually thinking of even doing a cleaner loft than what I'm going to show. The problem is, I also looked up to see how, because I didn't see anywhere a way to do a 3D sketch in Onshape. And that is because apparently there is no 3D sketch in Onshape. So like what I would normally do with a loft like this, right, where I want to connect between two weird surfaces, is do my sketches, of course, for the profiles because you need those for the loft. But then to make sure that like it follows the profile I want, I would typically do like a 3D sketch, sort of from here to here, and maybe curve nice and pretty, and sort of set things up the way I want it to be. But you can't 3D sketch here. And to be frank, when I did find sort of instructions like Onshape's, I don't want to call it a workaround. It's a conscious decision they made. It's not a workaround. It's a conscious decision. I don't entirely understand how their version of a 3D sketch works. So what it does, I can sort of demonstrate their alternative. So you would sketch, and it would be based around the mate connector here. So select mate connector instead of sort of selecting a plane. I clicked on the mate connector, and then the mate connector sort of pop up everywhere I snap to, right? And if I were to pick, and again, this was a problem I was pointing out last week, like I don't know how to actually get it oriented exactly how I want it, but I want it kind of facing me, so I'm going to hopefully stop my mouse in a position where it's sort of, right? There, that's what I wanted, that one. So now it basically creates a plane wherever I click that mate connector. And I'm sketching on that, so I don't have to have a plane ahead of time. and this is sort of how they work around 3D sketches. So you would do this, and let's say, I mean, basically from there to there, add a line. Um, and then, I mean, just because this is demo, I can accept that. And then I would do the same thing, sketch from a make connector on this point and sort of get it oriented how I want it. Again, still not sure exactly how to get this oriented precisely the way I want it. Like question mark, I'm not sure like exactly, like I'd like it kind of facing me again. And I'm not sure where the mouse needs to be to do that. But let's say, I mean, for argument's sake, I go there. So I'm on, that plane. I can sketch now from there. And this is sort of their, again, not a workaround, but you build up from make connector plane to make connector plane basically, and end up with a 3D sketch. Notice that's in a couple of different directions now, right? Those two lines. I will admit that in the 10 minutes or so I played with it, I don't truly understand, one, how to get those make connectors oriented the way I want them. Two, I would really like it on a plane like between these 2 points. In fact, can I just do a plane with 2 points? That I didn't try. Let's try it. Let's try it. Let's try to create a plane across those 2 points. So entities. I don't really want it offset. What about plane point? Can I do that? Here? Point 1, point 2? It didn't create a plane yet. What about here? It didn't like that. Did not regenerate. Too many entities. Okay. So let's deselect. Can I make a plane? It's just I mean, I'm playing around now. So simply what I played around with. Let's finish that thought first. I have a tendency. So I created these two sketches when I was playing basically this way. And now I played around with ending it at different points and making it look different. But the general idea was then to loft. And as my profiles, select this one and select this sketch, right? And I get a piece of material there. Now in this case, like with the pyramids, I was okay with the geometric look. I don't know if I'm nuts about it with the bridge that I'm sort of adding in, just from an aesthetic standpoint. So what I did to get an S-bend, now this is where I wanted a 3D sketch, because I could sketch a specific S, like a guide curve, and a loft then would treat that almost like a sweep path. That's why I wanted a 3D sketch. But to sort of cheat that a little, you can always set these end conditions to normal. And you can do this in SolidWorks too. And so this wasn't a surprise. And it forces it to at least start out perpendicular to the sketch you made. And so that's sort of a way to cheat the S-bend I wanted without actually having to sketch it, right? So I was thinking something like that. And like I said, I played around here. I played around with only half of this triangle's width. I played around with doing the exact same thing back to this surface, like under where the motor's going to be. I'm not sure I liked any of those. I'm just not sure I liked any of them. I'm also at the same time not sure a better way to get what I want. Like, I want something like this. I want more plastic there, basically as a support, just so that in theory, by doing it this way, if this thing were to hit a bump, hit some excessive force, hit a snag, and it's pushing sort of on that corner in this direction, this material would be eating most of that force and not all on our very thin vertical here. I'm not sold that I mean, part of this is aesthetic, right? A big part of this is trying to make it look nice as well as functional. I'm not sure I'm sold on that. So I think, and like I said, I played around with a couple of different versions of this. Let's get rid of that loft for now, just the feature. And back to what I was doing, I was playing with this plane to see if I could get a plane in a spot where I can sketch the guide curve that I want. I'm still not positive that that's actually what I want to do. But it's the best what about 3 points? I mean, I want to select 3 points, right? So I would, for a loft like this, sketch effectively 4 guide curves, one for each corner, and then it's going to sort of shoehorn the profile into the whole thing. So here, here, and here. That's 3 points, right? I'm gonna go ahead and sketch some. I'm gonna go do it real quick and dirty because I'm still not sold that this is actually what I want to do. I don't want to do a well, I mean, a spline isn't a terrible idea, I guess. I guess a spline wouldn't be a horrible way to go. I like probably building it out of arcs is probably more my style. So something like this and something like this. Oop, not line, arc. Something like this. And we've done this sort of thing before. I forget which feature we did, but I would set them tangent to one another. Tangent. I would also probably, in this case, set them equal to one another so they have the same radius. And then to set sort of that midpoint, this has got to be like vertical, vertical to that. And can this one still move? It can. So if I make this one vertical to this point, that should lock everybody down. Yes. Right. And that should, if by being vertical, it's at least, or should be at least at a normal, a 40 or a 90-degree angle to this face, because this face is vertical. This face is not, so we'll be, not quite at 90, but that's close. So that's what I want to do, and I'm going to do it 3 more times. It is worth it to me to spend the extra time right now to see if I can get the guide curves in there. And I haven't done a sketch with guide curves, or a loft with guide curves in Onshape. But I am operating under the assumption and doing what feels like wasting time in the interest of, because I have done this in SolidWorks, I don't know how many times, and this is sort of the way I would approach the problem in SolidWorks. So, well, I should say I would probably approach the problem in SolidWorks with a 3D sketch. That's not an option, so we work with what we got, right? I'm still fairly sold on Onshape. Like, I'm pretty happy with most of the features. Again, when you're drawing curves like this sort of freehand, make sure, like, dimensions will come. Just make sure that they are, bent the right way. Otherwise, that causes problems. So set those two tangent to each other. Now, rather than equal, I can't do concentric. They're not on the same plane. I was going to set them concentric to the can I? I was going to set them concentric to the existing ones. Okay, it'll let me. What about this one? Whoops. Got to grab the curve, not the center point. Curve. Can I do the same thing here? Nope. Okay. Did I already set them equal? No, I didn't. So I can't get concentric there. What if I set them equal? Is that enough to lock it down? I just want to see if the guide curve, that's enough to lock it down. I just want to see if the guide curves, I can come back and clean it up later. And I'll have to, because this isn't enough, there's not enough material here. Like I said, the PCB will be in our way. So we'll have to change it later. This is still just strictly experimenting. How can I get a decent amount of material in there to sort of give me the feature that I want to support, shore up this front pyramid shape. So I guess 2 more planes, 2 more sketches, and we'll just keep on chugging along. And again, I'm going through this because I think it's worth it. My feelings about this being too small are strong enough. Plan B, if I can't get material in here, Plan B would be to greatly reduce the size of the cutouts if I can. We have to take a look and remember that I need enough room to get the laser to shine through this hole. To add material, basically add material till it's strong, right? Just make that leg bigger. I think I like this solution a little better. I like the look of the pyramids, despite not knowing what I was doing when we did it last week and walking through it. I like how they turned out, like, aesthetically. So I'd sort of like to maintain that look. And I'm not positive that curved here is even, like, I might want to just do a simple curve down like that. That's why I said this is playing around. This is strictly playing around. The goal, like, I know I want a plastic bridge. Right now, that's all I know. I don't know size. I don't know exact location. I don't know exact layout. I played with a few of those things. But didn't actually come up with anything I was, nuts about. So we'll set everybody vertical there, vertical here, and that should lock you down, right? Yes. And that should be pretty close to the curve on the other side. In fact, it looks pretty close. And then we need another plane. So accept that sketch, and the last plane, these 3 points. Okay, good. And we're going to sketch our last curve on that. Now, all of this, very possibly in another minute or two, might just plain get deleted. I'm, again, willing to make that sacrifice. So which one of those did I set concentric? These? These were the ones that could be concentric. So I like that, concentric. If I go tangent here, and I did equal, right? Equal was the other constraint. Equal. Okay. All right, so I've got 4 guide curves, or what I hope are 4 guide curves. That should help guide a loft to make it look maybe a little better. Again, I don't know. I mean, this might not be the approach I want to take at all. Who knows, right? But we got our sort of naked loft. Before I do anything with end profile or anything, wants to be straight. Lofts always want to be straight. They're going to connect those 2 profiles and take their own path. You can see how the edge sort of twists. Going to take the path it needs to do to get there. I'm going to try guides and continuity. So guides, 1, 2. It does not like that. Oh boy, it does not like that. All right, I'm going to accept it, see what it doesn't like. All guides should intersect each profile boundary. Is that because it's a compound curve? All right, let's delete that. Because it had me selected as 2 curves, it didn't see that as a single path. So let's go to that. It would be that sketch. Oops, just that one for now. Just, again, playing around. I don't know. I don't know, and I'm willing to admit when I don't know. So that one's red now because I just delete. Let's go the other way. I'm going to put it back. I want to loft, and I want to make sure I get the same error if I select guides and continuity and select this bottom one. All right, it's going to be the same error. So I'm going to delete the last sketch instead. It went red because I deleted the reference for equal and the reference for concentricity. So on which plane? Which plane was it? This plane? This plane. I need to sketch it. I'm going to try a spline. A spline should give me 1 continuous curve. So here to there. And actually, I got to stop in the middle, don't I? Oh, it gives me the guide points. All right, so we can bend it there and bend it there and get something that resembles what I had going on up top. So that now should be 1 continuous curve. Let's see if it likes that as a guide. I may have to go with a spline if I like this end result. So loft, there, it's straight. Now when I select guide, you should see at least that bottom edge bend to meet this spline. Yeah, like that. So that's exactly what I want to do. That's pretty much exactly what I want to do. At least, again, this is an aesthetic check. Like, it's a question mark. That's what I want to do, question mark. I don't know that for sure. This is experimenting. So basically, I'm going to delete all these sketches, all of them, and do splines for all of them. So on this plane, sketch and do a spline. Again, I don't know. Maybe I'm just killing time. Oop, is that even on the right plane? Now, why are you... Why were you so far out in space? Like, if 3D sketches were possible, we wouldn't be in this mess. Come on, that zoom thing is getting annoying. There we go. that plane, sketch, spline, boom, boom, get out of there. Oops, get out of there, deselect, come on. We can do better than that. Cannot delete. I wasn't deleting the handle, I wanted to delete the spine. There we go. You need to go that way. The thing I don't necessarily, now can this, what I was going to say, the thing I don't necessarily like about splines and manipulating this way is that it's hard to control actual dimensions. Like if I wanted an actual radius on this curve, that's kind of tough. But can I grab that as a thing and make it like horizontal? I'm just curious. Yeah. Okay. So that is an actual entity that I can constrain. Cool. And then if I drag it, it'll sort of move. Yeah, that's what I'd expect. Cool. I'm going to make it kind of match the sweep of the bottom one. It won't ever exactly because two different heights. But that does not look unreasonable. It's going to look always kind of funny because we're drawing a curve on a flat plane, connecting it to an angled edge. So it's always going to look kind of funny. But again, I'm just trying to get a feel for if this is even the solution, adding a bridge in here. It may not be. I'm hopeful. Let's make this horizontal. I kind of like how that ends up because that should end up being the same thing as sort of making it normal to the profile in the first place. So that looks fairly close to what we've got going on the other side. Accept that, and then which plane? It was this plane. Is the bottom point. Sketch a spline on that guy. 1, 2, escape out, and then manipulate our guide handle. So horizontal. I want you horizontal. Check it against the back. We got a little more. Actually, can I go normal, view normal to... Can I view normal to that? Yes, I can. It flipped me wrong side up, but yes, I can view normal to that. And that's a little better view of what I'm trying to see. So make that a little more bulgy. That looks pretty good. Again, for experimentation purposes, that looks pretty good. So let's loft here to here. We are straight. Let's grab the guides. Hopefully, I can grab all 4, 2. And that's exactly how I'd expect a loft with guide curves to behave. So let's accept that. Do I like that? I mean, the other thing is, while it's geometric now, like everything is square now, like the last finishing step, the plan was always to fillet a bunch of stuff. So do I like it curved? Do we want it straight? That's another question I'd have to ask myself. The other thing is, I don't have to draw like a bridge. I could sort of come off of this with just like a leg to here and a leg back to here, or even a leg here and a leg all the way back to here. That might not be so horrible. That might not be so horrible. Sort of a leg. And could we even go... Yeah, I was wondering if we could go to that flat. Then we don't even have to get the PCB out of the way. We don't have to add material. I don't know if going to that flat really helps us much. I really am worried about like the support dead on from the direction I'm looking at here. That's really what I'm worried about, is this direction. This direction, like from the front if it hits something, this leg is nice and angled and pretty beefy. It should be able to handle it. Same with like dead from the side. It's really sort of in a range from this like 45 that worries me. So really I want support in kind of that direction, but it's going to help us if I were to do a thin leg to here and a thin leg back to here. It's still going to help the problem I'm looking to help. Right? It's going to help. I mean, the other option is also to go back to like what I had planned originally last week and just drop these cylinders, which are the screw holes for the main PCB, drop those cylinders all the way to the floor and just call it a day. I'm not nuts about that idea. I kind of like. I'm going to go ahead and delete everything we just did, all the planes and everything, all of it, because I'm not sold on that. Also, these two sketches can go. I'm not sold on that, on the bridge idea there, because I really like aesthetically. I can't express how much I like what we've got going on with the pyramid thing. One thing I might do, I want to try to thicken this up. So make this, just make it bigger, make it not 1/8 of an inch. I really like aesthetically this look. I wish I could get more angle out of these back legs. I can't really. I mean, I guess I could. How could I do that? I mean, if they weren't. Muted myself to cough and then started talking again. Great, great. This is why I'm not a professional YouTuber. I'm an engineer turned teacher, I guess. What I'm noodling over right now is I cannot, if we go back to the assembly, more angle is better. Like, angle is strong, right? If I could somehow tie this bottom straight back to this motor, that would be the absolute strongest it could be, which is also the most wicked angle off of the vertical. That it could be about, it could get even worse. I could go straight back to some support. That would be even better. That would eat the most amount of force. That would be the strongest. But having more angle back on this would be stronger. I can't do that because I'm going to start to get into the motor. So this is where it needs to be. I could go further out with this one, but going further toward the middle doesn't help me at all. What I'm thinking, this center post right now, the way this is modeled, this center post, is out there almost entirely on its own. Okay. What I'm thinking is it's out there almost entirely on its own, this center post. And what I'm actually thinking is instead of a 3-sided pyramid shape, going to a 4-sided pyramid shape, I could throw another leg back in here. Now that's going to be almost vertical too, I can tell by looking at it. But it's better than one leg. Plus these will get thicker because they'll be coming in at an angle like this. I'm going to try that. And it's simple to try that because one side of this was just a mirror. And I did move some features down because when I put the pyramids in there, I encroached on my screw hole. So I slid those down. I slid those down in the screw bosses so that I wasn't encroaching on the hole, right? I always said, like 6 weeks ago, like episode 1, I said I could always move these down if I started to add plastic and get in the holes, and I did. So, but this mirror here is this side, so literally I can just delete it and really not lose anything because I can always re-mirror this one. I can leave this one alone for now because I like the way that looks. I do, and it clears our laser and everything else. And then I can sort of play from there. So I'm going to sketch and make sure I get a good bottom view. I want things vertical and whatnot oriented correctly. I'm going to sketch. I know this point for this corner is going to end up across from this one. It has to. But I can come up in here somewhere. I don't know where yet, but somewhere up in here. Somewhere up in here. And just come across, right? So it's not a square. I don't want to give anybody that impression. It's not a square. And I grab this and this, and I should be able to set these equal. So we're comparing apples to apples and seeing how we do. Make sure it's that one because we're on that face. It's not a square, but it will give us another leg back here. Now where that exactly that lands is also going to matter because I've got screws to clear, right? So I can still get a screwdriver on those, and I've got that sensor to worry about. So, I mean, this is not easy what I'm about to do, but it does, I think it will help the problem a little at least. Again, I don't know where that needs to land, so I'm going to leave those blue and unconstrained, and it'll leave a little mark here, almost like a little, it's blue, but it's like a caution symbol. That'll remind me that that sketch is underdefined, which is okay for now, because, like, I don't know where it wants to be anyway. And the plane, where are the planes I created for that? I created planes because I lofted. There's there's a plane. Is that the bottom? That's the bottom plane. Okay, so plane 6 is the one I want to sketch the bottom profile. That would be this. Um, that would be that. I already don't know. I can sort of envision in my head what this is going to look like when I loft it. I don't think I'm nuts about it. We'll see. We'll see. I don't think I'm nuts about it. The other option, now that would it help if this whole triangle sort of slid in? That means, we'd still be under tension if that thing got hit. I think, honestly, the triangle idea, I like the look of the triangle type pyramid. It looks kind of cool to me. I could be way wrong. Like, somebody may watch this video and think, you idiot, that looks terrible. I kind of like that aesthetic with what else we've got going on here geometrically. I'll finish it. I'll finish it and give it a good shot. But I'm almost thinking I am not going to like how this sort of four-sided deal turns out. So, if we're going to go four-sided, I might as well make it a rectangle on this, the bottom of it, what would be the floor end of it. And we sized this so that the circle we needed for this screw boss fits in there. What's the diameter of that? 1/2 inch. So really, this square I just threw in there, rectangle, needs to be 1/2 inch on a side. 0.5, and I'll make these equal just so that it's square, right? Then I only have to ever change one dimension. And as far as placement goes, doesn't have to be where this one is. Like I mentioned, I could move it further back and in, but I want it inside of this point. I know that, so I want it in this profile. I think probably the easiest thing to do is going to be to come out to this. Oh, I can't grab that edge. Can I do coincident to that edge? That'll work. Coincident. This is going to be construction, and I'm not using this, like I've used this method in the past to center things. Right now I'm just going to use it to distance things, so that it's equidistant from both the oops, that needs to be horizontal. We can always fix that with horizontal. I'm just going to use them, not construction, coincident. You need construction on the line. Why is that not coincident? Undo. Why did that not go coincident with my actual edge? Coincident, please. Get a good bottom view, make sure. There, okay. Now construction. So really all I wanted to do with those construction lines was make them equal, so that when I dimension one, it's sort of equidistant from both. And actually that's not a terrible spot there, so I'm going to end the final dimension pretty close to that. What does 375 look like? 375, yeah, okay. So that's really all those two lines were for, was to make that equidistant. And then I'm just going to loft between those two. That was the plan. Loft between this sketch and this sketch. Right? That was the plan. In doing that, that plane, this is not a plane anymore, so I won't be able to hollow that out the same way I did the triangle, because this isn't flat. See how it twists? It's hard to see, but that's not flat. There's a good view. It's a curve, which means I can't sketch on it, which means I can't cut into it the way I did the other side. If I accept that, like even if I skeletonize that, I don't think it's going to help that much, and it doesn't look great. So let's go ahead and undo that. Let's undo that. It doesn't take much to undo. Seems like so far this entire stream has been undoing iffy ideas. So, I mean, plan B was always just to make this thicker, so let's see what I can do to make it thicker. So first, there were two lofts involved in this pyramid. One to create the outer pyramid, one to cut out the center. So let's start there, and I have to remember which features those were. This second loft is the center one, and that's going to basically define this width from here to here. So I'm thinking of editing that, and adding more material. And actually, I need to edit the sketches. Edit. So rather than an 1/8 of an inch wall, can I get a 1/4? I doubt it. Let's do an 1/8 of an inch on the back, because that's kind of okay. And thicken up just the front. What happens if I do that? It won't be symmetric anymore. But it gives a lot more meat on that leading edge, and that's really what I'm worried about. So do that. It's going to lead to a really weird geometry, and then I got to do the same thing to the sketch that started that law. Ooh, a lot of sketches broke. A lot of sketches broke, but that's okay. We can fix anything that broke. And again, I think it's been a while since I mentioned, but I have mentioned before. We're at a point in the design where there's so many things, constrained to so many other things that it is very possible to break things along the way. It's easier to sort of keep track. Ooh, ugly. This should be a 1/4 inch now, though, if I measure it right. I'm over a 1/4. So I like that better. I do like that better. I can't go back further. I can't go back further because I'm going to get into the motor if I go back further that way. Again, if I go back to the assembly, you can see what I'm talking about, right? If I can't go back any further because I'm going to get into the motor on this edge. The only way I could go back further and get this to be a 1/4 is if I made these two sides not equal anymore. Made this side longer, and then I could come in towards the center a little, I think. And actually, now's good. Let's look. Is my laser still clear? Ooh, barely. I mean, it's kind of asking for trouble, but it kind of is what it is. I mean, I don't hate it. Oh, remember, this is going away. Like this triangle, this inner triangle is going to go away. That exists strictly for the purposes of hollowing out the pyramid. That's all it exists for. So, I mean, realistically, let's go back to the chassis, and I'll take care of what I'm talking about like right now. So we need this depth from there to get a threaded 5mm insert in. That depth is 625. So on here, I'm going to extrude. Well, first I need a sketch. You got to sketch first in Onshape. But I'm going to match this triangle, and I'm filling that hole. That cutout, that little cutout triangle is always going to go away, and it was going to go away this way. So I'm not doing anything I hadn't already planned. But I need to go there. I'm going to grab that sketch I just created, extrude it. What did I just say? 625, and flip the direction so that it goes up. That was always the plan, right there. I don't need to add that much material. In fact, I don't need. Well, let's do it. I don't need to add that much. It can be open. I just need. I mean, what does it look like in the assembly? Is that the laser's the guiding thing out, right? I wait for this to update. I still haven't found a way to force an update. The laser's still clear, but that's no longer kind of as sleek and as nice looking as I was hoping it would be, because I don't know how to. Basically, I don't know how to fill out. Oh yeah, I do. Yeah, I do. I know how to fill out those gaps and make it nice and sleek and look like it belongs that way. I do. So it requires extra steps, but sometimes extra steps are necessary. So I don't know if it's like the correct way. If like CAD professionals, guys that do this for everyday living would do it this way. There's probably ways that I could just do another loft or something and do this step. But the way that I would do this, and since I'm the one that's doing it, the way I would do this is I would grab this surface and sketch on it. Oh, we gotta be in the chassis. I would grab this surface and sketch on it, match the outline of what I see here, and I'm hoping that everything is sort of parallel, because otherwise this is going to suck. It's going to turn out terrible. It's worst case, it just doesn't work at all. I would just do that, and then extrude that out to a face instead of blind, up to face, and select this outer face. And that should, if everything was parallel, it's not. It's not, because that should have blended in nicely, and it didn't. Okay, so next idea is to get rid of that sketch, do the same thing but in reverse, do it on this face, and extrude up to this face, and see what we get. But again, outlining this time the outer shape here, here. Make that coincident with the top so that it's nice and even. Can I view normal too? I should be able to. Okay, and then grab that and do an extrude of that. That sketch to a face, and grab that face. That should fill us in nicely. Little weirdness here, but honestly, that little bit of weirdness that we're seeing now is going to be an effect of, how do I want to phrase this? That's going to be an effect of basically looking at a perfect SolidWorks or a perfect Onshape part. When that's 3D printed, like, we're never going to know that little bit of facet is there. We're just not. It's, if you look at how low that angle is, we're never going to notice. But I kind of like that. It's not as sleek as I was hoping, but it still gives us sort of everything we need. Our window for our laser is getting really tiny, which is okay, I guess. Cool part is, like, when I go to finish this, again, fillets was the plan. Half inch is going to be way too big for what I want to do, but let's do like 1.875 and see what happens. Like, if I fillet these corners and go all the way down here, right, things get a little sleeker, a little prettier, and that's also why I wanted more than 1/8 of an inch of material so that I could afford to fill it. Now, of course, this one in the back gets kind of ridiculous because of how sharp that angle was, and those actually get really thin now. I might shrink that fillet a lot if I do it in the back. 1.875 might be way too much. That looks kind of cool though. That looks a lot better filleted than it does sharp with this extra, like, chunky bit of material in there. So we'll deal with that, but I want to get these legs finished because, I mean, my God, going from, like, with 20 minutes left in the stream last week to having those pyramids in there, not knowing they needed to be there at all or forgetting about them, to putting them in, I've now sort of given them more time than I really wanted, because I was hoping that this thing would be done by now. Like, I want to print one and put it together. I'm getting a little itchy. So again, extrude up to a face and grab that interface, and we're just looking to close. We're just making it pretty, so this is all flush, right? I don't want these little indents. There's probably a way too. I mean, there could be a way to sell it and make those indents aesthetic, make them look cool, like they belonged. But again, that might be more time than I want to spend here. I definitely, I mean, a key takeaway here is, like I mentioned toward the end last week after I got these in, I didn't compromise on, like, I didn't know how to get the shape that was in my head, and I didn't compromise on it. I sort of tested until I got it right. Even though I want to be done, we don't want to go blind, we want to go up to a face, and again, that face. Um, so there, we're closed in. The thing to do now, what size hole was this? 257, but what drill bit? That's an F. So an F drill, half an inch deep. And again, I could go shorter. In fact, I probably should. So if I go just a half, if I go a half an inch deep, and just drill it through, that's better. That's less chunky. Let's do that. I'm going to change that. Was that the sweep I did, or I got to remember now? That was an extra extrusion I made up. That was that extrusion right here. Add it, and instead of 625, let's just go a half. It makes it shorter. That'll make it more aesthetic, I think. Less material. Like, I liked it thinner, but we have to have a certain material thickness to get the threaded insert to sit right. All right, and I'm going to double check in the assembly now. I want to make sure our little laser is going to shine through there. View normal. So we should be clear. As long as this box is clear, we should be okay. And we got some wiggle on each side, up and down. So we should be okay. We're shining right through that gap. And again, I can fillet that to now. Now that it's a 1/4 inch, I can fillet it and feel a little better. I can even cut the fillet down to like 50 thou or something and feel a little better about it. But I'm going to drop, we got to be back on the chassis to drop the hole in. I want to drop the hole in. And I'm just going to center it in this rectangle. This triangle the best I can. That's not going to be particularly easy. I mean, yeah, maybe it could be, I guess. We don't want it necessarily centered vertically. The actual middle point, like if we equidistant from all three sides, is going to be short. Like if I drew a construction line from this point to the center of this side, the actual center point where this is equidistant from all three sides isn't going to fall on the middle of that line. It's going to fall slightly south of the middle. So the best bet is just to, actually I can delete that and just use the point of the line. Just come here with a line to the center. Come here with a line to the center. And come here with another line to the center. Basically set all three of those guys equal. Why don't you give me the middle? There it is. Middle. Thank you. Midpoint. Okay. All three of these, if I make them equal now. Alright. Ooh. Do I want to be that way? So I was wrong. I was backwards in my geometry. North of middle. Is that where I want to be? I feel like I want to be back. I feel like I want to be back. Let's try doing it with a circle instead. Actually, what is that? 257. So I've done this before too in SolidWorks. Sort of use what the finished hole is going to be, and sort of get this guy in the middle. Which should be, I mean, just visually, like, right there, right? Why does it want to be so far north of the middle? That is odd to me. It's a trick of geometry that, at this time of night, I'm not quite grasping. I don't remember. Well, I can go back. Let's accept that sketch for now. When I originally sketched this, I remember doing a construction circle. I just have to remember which sketch that was. Was it 38? This is where naming sketches and naming features comes in handy. Let's edit that sketch. Somewhere, okay, it wasn't that one. It must have been the bigger triangle. So it's 38. It wasn't this one. Edit. Somewhere, I did a construction circle. I remember doing it. There it is. Right? Was that the one? I thought I did a construction circle. Did I not just see a construction circle? That's the circle that I just drew. Anyway. Okay. I mean, maybe I was wrong. I could have swore I did it that way. Let's edit that sketch. Let's try to get that guy centered in our. So thinking geometrically. Thinking geometrically. If I go point to center, all right, this bad boy is going to be for construction. If I put this on that line as coincident, not middle, coincident, and then if I go from that point to center and this point to center over here, and then make these equal, is that what I'm thinking? Yes, but it didn't. Maybe, but it didn't lock it down, because I can still move. I can still move, and if I make it equal, it's going to pop it way up there. Something about that doesn't feel right. Is it not? Maybe it's not the center I want to be equal, but the distance to the edges, but that's still going to pop it way up. Like visually, center should be somewhere in here. It's not quite in the middle. It should be south of the middle. I'm just blanking on, and I know I've done it before, you know, dozens of times in the past. Maybe center to these is not the way to go. Maybe it needs to be... I wonder if that's it. Maybe that was why I'm off. Not center. Vertical and horizontal, I'm thinking. So here, do another line vertical. So not centered on the sides, but then these need to be equal. And now I'm going to go to the center here and make this equal to those. There we go. That's the geometry I'm looking for. That looks visually centered. Like this wall here will be the same as this wall as the same as this wall. That's the trick of geometry I was looking for. Go ahead and accept that. Use that sketch to create a hole. That was a F, number F, number F. I'm going to stick with that, number F. A number F drill. I am going to deselect all but that center point, which is easy enough to do in Onshape. I kind of like their hole wizard, by the way, in Onshape. Hole, that needs to be at least 0.5 deep, which is going to punch it through, which is fine. We're going to flat bottom it. And actually, I'm going to go a little deeper just to knock off that little corner that you see right there. It's leaving that little bit. I'm going to go, actually 75. I can afford that because it's not going to hit anything. That's strictly to knock off that little corner. That's it. Just to knock off that little corner. And if I really wanted to, I could just slide that hole back a little bit, which would leave me more material. And actually, that's probably the way I'd rather do it. So let's edit that sketch, not the. Let's edit. We need to change our construction a touch. I want to get rid of the equal constraint on this. So that one floats now. Let's undo. I want it back where it was when I started. So the equal constraint is in place. All right. I want to now get rid of it. So I'm floating, but I want to dimension it because I want to know what it is now. It happens to be a 1/4 inch. So let's go 0.2 and see what it looks like. That's way too far. Tell you right now, that's way too far. I just want to get clear of that corner so I'm not biting into that front leg. There. Just like that. Just back enough that I'm not biting into this front leg. Leave as much, like, we just fought to get more material there. Leave it as clean as we can get it. Now, I need to go back and make sure, all right, my hole here is still open. One thing about this that has been bugging me, I'm going to check it right now, is why these extra little, like, bars exist. I'm not sure. I think it's because of the way I cut through to skeletonize the pyramid after I hollowed it out. So that's what I'm sort of going to dive in right this exact moment and see where those sketches are that hollowed it out. That's one of them, right? No, that's the fill-in sketch. Those would be way up here. That is one of them. So it's going to be sketch 40. Sketch 40, let's edit that and see I remember why we did it. Because if I go too close, like if I went and got rid of this dimension, let's just get rid of that dimension and I'll show you why I did it that way. And if I make it, like ideally it would be perfect in line with that. So I'm going to do that, make it coincident with this line. And accept that. If I do that, then we bite in to our surface, and I don't want to do that. So how far offset? Now, good. That's a good question. So really, that 50 thousandths dimension I deleted needs to be this distance, in theory, which is 40. That should, it won't eliminate our bar, like this bar, it won't eliminate it, but it should at least end us up flush, which is better than where we're at now. So undo. Can I undo that change? Yes, I can. Awesome. So instead of 50,000, I got to find that sketch again now. Oops. Let's grab that surface because it should be, okay, sketch 40 is one of them. Edit. And instead of 50, we're going to go with 40,000. And I need to change whatever sketch made this hole. Should be 39. Edit and do the same thing. 0.04. Okay, I should end now flush. Am I? Pretty darn close. Like if you zoom way in, how far apart am I? 1.67 e to the minus 4. I mean, for what we're eyeballing here, that's about as good as it gets. It doesn't get much better than that if for what we're eyeballing. And the fact that it's not flat, it's at an angle. I don't want to, I mean, I could do all the trig to figure out exactly how to get that guy flush at the end. Not worth it. It's frankly not worth that effort. So I'm going to leave it that way. Now, I do want to move this one up to get rid of this bar as much as I can. So what's that distance? 30 thousandths. So we need to grab this sketch and edit it the same way and take it down by 30. I don't know what it is right now. It's 50, so 002 should end us flush-ish, right? Yes, and if you zoom way in, again, there's a shelf way in here, e to the minus 5. So, I mean, it doesn't get much closer than that through eyeballing it the way I did. Like I said, in a perfect world, I mean, my whole, moral of these legs is to not settle. I've been trying to hammer that in and don't settle for sort of second rate. What I'm doing right this second is I'm settling. Right? I can't get flush. I'm settling. I justified it by e to the minus 4 and whatnot. I don't want to settle. So the real way now is it, well, can I? I mean, no. I was going to say what I could do is take a cut, sketch on this face a cut that's in line with this and this. I can't do that though because nothing's straight here. This surface, if you look at it from the front, that surface faces us, so we'd be cutting into it if I just cut out this material flush. So I am going to live with that shelf, right? It went from, so a second ago it was a cop-out. Then I checked into doing it what I would call the correct way, and I just can't do that. I just can't. So it went from being a cop-out to just being the way that it is. That's sort of how some of this this design method works, right? I tried it, it wasn't going to work. So that's life. That's life. So we'll go with that. We'll go with what we've got. Now, we need to first, I'm going to move, I got to think. So those are holes. Those are screw bosses, and that is, all right, so this and this have to go to the bottom, right? Well, they don't, all right, they don't have to go to the bottom right now. They do need to go to the bottom at the end so I don't encroach on anything again. But the reason I'm moving them right now is now everything from here up to here, all of this, all the features in between, are going to now be my new mirror. And moving those down just made it so I didn't have anything in between and everything I need to grab for the mirror. So everything here, everything has got to get grabbed. Loft, everything there. I don't need them. This mirror was for the wire hook. So now I'm going to mirror all of those things. It's going to be not a part mirror, but a feature mirror. Oh, and then I have to reselect everything anyway. I keep forgetting that. Select all the features to mirror. And then at the end, I got to remember to check that whole reapply feature thing. There. Reapply and mirror about. I hid the plane. It's going to be the right plane. Reapply. I thought I checked that. Did I not actually click it? Okay, and notice when I do this is why the screw boss, I'm going to leave it while we can see it, I'll apply it. Notice because now the mirror is under that screw boss, it's going to cut into the screw boss in a way that we can't have. That's why the screw boss has to end up below those legs so it's intact. So now I'm telling it to extrude that screw boss and drill a hole after creating this skeleton leg. And that's sort of where we're going to have to live for now. Those legs now should be finished. Let's go pop the purchased components into them to make sure. I can do that. I can do the insert now. I don't remember. I gotta remember what the part number for the 5mm. So main PCB heat set insert A180 is the insert we're going to use here. So insert, and in my parts should be an A180 right there. I need one of them. I need two of them. Okay, let's go with a Revolute mate. On this and on this. Drop it in, reverse it to drop it in the hole. We could make that shorter. I'm gonna, now seeing how that goes in there, I'm gonna make it shorter. I'm gonna make it just the height of this insert. I don't remember, there's a minimum material thickness called out on the drawing for these on McMaster's website. I gotta be honest, in this application, I don't care. I straight up, ooh, that's getting real close there, but that's okay. That's okay. I don't care. I don't care what the minimum material is. At this point, these are now, like let's say they're front and center. They're aesthetic, and I liked this bottom thin as I could get it. It was this leg I was worried about. So I'm going to shrink that back down. And like from here to here is how much. How tall is the actual insert? The insert is 374. So I'm going to go 375 on this extrusion that I created. Back on the chassis, way down toward the bottom. It's one of these extrudes. That extrude probably right there. Edit that and go 0.375. Keep it as short as I can, right? All right, my mirror updated. Go back to the assembly. It probably takes a second to update. I have not found a way to force it. Like this seems like it should force it to update, but it doesn't quite. Okay, so that's as thin as it's going to get. Now it completely fits that insert. It may not be per the drawing like the minimum material thickness they want, but it'll definitely work. And I'm good with that. It's kind of svelte and thin. I'm encroaching again. Oh, because I got shorter. We're on an angle. I shortened it up. See, I shortened it up. Now my hole is again encroaching on the leg. So I need to move the hole. In order to shorten the boss that I just shortened, I need to move the hole again. So this is again how cascading things in a design come back and go back and forth, but that's okay. Because we've still got some real estate to play with. We're not getting into sketchy territory as far as hole placement yet. I don't probably need to back it up far. Let's try 0.215 first. That's just 10 thousandths back. And do that and see if I'm still encroaching. I am by a little bit, so probably 2.1. Again, I'm just gonna squeak it back. Not the whole, the sketch. I'm gonna just squeak it back little by little until I just don't encroach on that anymore. There's plenty of material here. I'm okay. I'm happy down here. 2.1. Let's try that. Oh man, ever so slightly. I'm gonna go 205. I'm gonna go 205. Ever so slightly. Just squeak in until 0.205, and that should still leave us with plenty of wall thickness. It's not equal anymore. Like this side is not equal to this side anymore, but there's still plenty of overall thickness there. We're not encroaching. Okay, I'm gonna leave it there. We're good. All right, go back to the assembly. It might take it a second to refresh again. Nope. Yeah, no, it refreshed. Okay, now I did not grab the actual feet for McMaster yet, so let's go out and do that. And go McMaster, and we were going to use a not a heat set insert. We were going to use a spring-loaded ball plunger. That's Plan A. Remember, Plan A is spring-loaded ball plunger. Plan B, long-distance spring-loaded ball plunger. Plan C, carriage bolt. The M5 can accommodate all of them. And in fact, we set the height off the floor of that to accommodate a carriage bolt in the worst case. We sort of planned ahead for Plan C, hoping that Plan A, ball nose spring plunger, works. All right, I need it metric, I need it M5, and I need the longest one I can get. We don't want the driver, we want the ball. Well, nose force extended. Well, yeah, because of the high force. Steel is cheaper. It doesn't need to be stainless. There's no reason in our application it needs to be stainless. Product detail, let's download. Oh, lock, that's right, locking. No thread locker, please. I want to be able to get it out. Step file works. We get it imported into here. Now, it's only a ½ inch long, and that worries me because that may not give us a lot of engagement in our threads. But we'll see. What was I doing? Import. We'll see. It may not give us a lot of engagement in our threads. Import appearances imported into this document. Yeah, that's fine. That's fine. I didn't check the, again, composite part thing because, again, I'm not entirely positive exactly what that's supposed to be doing for me. One other thing we're going to move eventually is this hole to get our wires through, because we need to cut through that little artificial beam we created with the triangle. So that this square hole is going to get moved again toward the bottom of the. All right, there's our ball plunger, and see, it's like a little pre-canned mini wheel in theory. The only thing I'm worried about is, again, like on carpet, there's not a lot of clearance here. Like this ball isn't very big. We might snag on the threads and or on the driver's slot, which is where like extended nose spring plunger Plan B comes in. And again, in worst case, Plan C, the carriage bolt, right? Again, that's the plan. So those aren't going to be long enough. I'm looking at that right now. Those are not going to be long enough. But we split the difference, right? Didn't I set this height? If I remember right, I split the difference between... Carriage bolt is the longest. This is the shortest. And I think I split the difference with where this height is here compared to the wheels. So that with this, we would run slightly nose down. With the carriage bolt, we would run slightly nose up. That's why I split the difference so we could accommodate all three versions. So yeah, if I remember right, best way to mate that to, well, I sort of want all thread engagement. I want it all. So let's try a revolute. I'm going to grab this back diameter if it'll let me. I want what I want and what I get are going to be two different things. Maybe I want this diameter right there, actually. And I want that to be mated here, to all the way up, and then let's flip. Right, that's how I want it oriented. Oh crap! That's our standard. I need to fix the parts and then group them together problem. Fine. Cancel. Cancel. Where is that? He said it's for plastic ball and spring plug. Oh, that is a part. It's a single part. It's not two parts. Well, it is two parts. They're not an assembly, though, so I can't fix what's not an assembly. Can I? Can I fix? I can't fix it. So in here, can I redo? I can't redo. How do we... How do we solve that particular problem? Well, first, let's use a slider instead of not a slider, cylindrical on this, this surface. I want the diameter. Grab me. I want the mate, that one. Give me that one. And I'll just remate the ball. That's the quickest. Okay, there. To mate the ball, I'm going to use a revolute mate because that'll force this to be flush in here. Flip it. Thank you. All right, and then because I did a slider, let's get out of the mate. I should be able to slide it down. Yeah, I can slide it down. It's being a little... That's not tall enough. The pyramid needs to be closer to the ground. And I could have swore we did some calculations last week that accounted for that. Did that get lost in translation somewhere? Well, let's grab a carriage bolt, because I remember talking about splitting the difference. So I'm going to grab a carriage bolt, and the carriage bolt is going to sit higher. The robot will sit higher with the carriage bolt, because the carriage bolt has an extra like 5 millimeters of square that's not threaded. Carriage bolt. We need an M5. It's length. Now, length, I'm going to just pull one up. Length, I think, is the length of the thread, or is that overall? Length is the length of the thread plus the 4 millimeter square. See the 4 millimeter square that's not threaded? So we accounted for that, I thought. But we may still be too high, and I may be able to make those pyramids closer to the ground, which will sort of help everybody out. So 12 millimeters, that's 8 millimeter total. We want, it doesn't really matter, because it's open, right? We can thread it as far as we need it. So let's go with an inch, 25 millimeters, an inch long. We got the room. It's adding weight. Like, extra length is extra weight, but right now, I'm not too concerned about that. And let's import that step file we just did. I'm not too concerned about the extra weight right this second. Now, once one of these is like built and sitting on my desk, maybe even driving around on the floor, we could iterate one more time. Once we decide whether plan A, B, or C is actually the one that's going to work. Because right now, plan A ain't going to work. Like, there's no thread engagement right now with how I've got this, how far I've got it run out to hit the floor. And it's not even on the floor. Like, this whole robot's going to be tipped nose down. So those, for these spring plungers, those pyramids really need to be taller. Like, a lot taller. Like, down into this range. Like, at least half of the threads that are sticking out here. And that's still only giving me half engagement on that plunger. But we've got now the stainless insert. So let's insert one of those and see where the stainless insert, the stainless carriage bolt. Let's insert one of those and see what happens. Do I have to open it first? It didn't show up in the list. Maybe I gotta open it first. Insert. There it is. I might have had to click on that tab first. All right, so that's in there. Now the goal with carriage bolt was always to run it all the way up. That was what I thought we had planned for, or I had planned for. I say we, as if I'm blaming you. We want a revolute mate. There's a nice diameter here that I can grab if it'll give me the right mating connector. If it'll give me the right mating connector, I want the one centered in this diameter. So this is kind of annoying. Again, the fact that I can't get, I want the center. Is that the center that I grabbed? It looks like it. I need to play some more with Onshape in general and get a feel for how to get the mating connector that I want. That's sort of annoying me to no end. So we'll accept that, but that's up there, that's flush. Yeah, we're way high in both cases, like ball plunger and carriage bolt. So something got kind of screwy. Not sure what that something is right now, but we can add a lot of height somewhere. My math was off. So let's look at a front view. Like, oh no, that carriage bolt is down there pretty close to the wheels, right? Why is it not? It's not straight because I didn't grab. It's okay. It's not straight in the hole because I didn't grab. I didn't get the right mate connector. That's why it's not straight. So I guess I'm not too worried about that. It's also not quite even with the wheels, but it's pretty darn close. And if we lower those pyramids, oh boy. If we lower those pyramids closer to the ground, I mean, carriage bolt may have to be plan A. Carriage bolt may have to be plan A. So I'm going to go ahead and make the command decision right now. The carriage bolt is plan A. We're going to go ahead and delete these spring. I don't know why they came in that way, not as an assembly, but we're going to delete spring plungers. We're going to go with carriage bolts. I am going to grab a shorter one. And it's angled, but will it give me a good enough measurement in here somewhere to see how far? I need metric. We're dealing with metric, millimeters. So blue, I can go 12 millimeters shorter and be okay. I went 20, it could be, I grabbed it at 20, it could be 8, right? This is a 20? 25. So like let's split the difference. It could be probably that 12 right there. Let's go with the 16. It'll be a little long, but that gives us full thread engagement. We'll download that and we'll get it imported. And I think we'll just suck it up. I liked the spring plunge ready is awesome because that really is it's a nice smooth round ball. But I mean, if it's not going to work, it's not going to work. We know this works. Like, we've been running these robots around on carriage bolts for quite some time now. So 413 is the one I want. And did I have to click that tab? Nope, 413 is right there. Maybe it just wasn't done processing. 413. Oh, that's the wrong one. 413, the short one. 413, the short one. Thank you. Accept. Now delete. And now let's fight with mate connectors and see if I can get the right one. We want a revolute mate because we want things nice and snug. Is there a better diameter to grab? I don't see one. Like, give me the diameter that I want. I want that one right there. The one that disappears as soon as I move my mouse. I want the one in the middle. Give me the one in the middle. That looks like it should be the one in the middle. Is that the one in the middle? Flip. Is it straight? Holy crap, it's straight. We got the right one. Alright, so we'll go with that. We'll go with that carriage bolt. That's pretty flat, that robot. We could probably go a touch taller, not much. Frankly, not much. That's about as good as it's going to get, I think. So I'm happy with that. I'm good with that. Again, I had a plan in my head. The carriage bolts, or the spring plungers were kind of a cool idea. I tested it. I ran through the options. It wasn't going to work. It would have worked. However,
we were all the way down to plan C with carriage bolts, but I knew plan C was a known quantity. Like, I know it works. The plungers were going to always be an experiment, and by going with that experiment, it wasn't going to allow me to go with the known quantity. Like, if the experiment failed, I'd have to redesign this to print another one. I don't want to do that. And that's the way I sort of look at these designs quite a bit a lot of the times is, all right, it was a cool idea, but I know the maybe not so cool idea will already work. Go with the one that works. Now, ladies and gentlemen, an hour and a half into what I claimed was going to be the final 2-hour episode, I am finally ready to start prettying this thing up. First thing I'm going to do is move the chassis back to the front, because when I import parts, it moves more tabs in. So let's go back to the chassis. I need to grab this cutout and move it down so that we cut through this material. Because that we need to be able to fit our connector through there for these sensors on the bottom. So that is that extrusion. That can move all the way down to the bottom of the, down to the bottom of the model tree. And once I do that, it'll cut all the way through, just like that. Looks kind of ugly. Ooh, looks really ugly. Yeah, we're not going to do that. We're going to edit that depth of cut, edit. Up to face is not really what I want. Can I go up to a vertex? Can I just make sure I cut through? Will I do it? Oh. Now why did that one turn red? Which extrusion is this? That should be a screw boss, right? Check input, edit. Oh, that's the cut for wires. Why would you break? Why would you break? Can you not be that low? I didn't base anything else off of you. Let's move way up above the lofts again. Just in case, way up above the lofts. I don't understand why that broke. Like what is that based on that would have broken? Edit. Vertex of mirror 5. What don't you like? Sketch 27. Sketch 27 is way up here. Okay, what don't you like? Up to vertex, up to face. Was I editing the wrong frickin' feature? Is that what happened? Like I grabbed the wrong one? Like here's extrude 19, that's the hole I want to be editing. Did I grab the wrong extrude and make it a vertex? Alright, edit. Alright, I don't want through all. Let's try vertex. And just go up to here, just to cut through this beam. No. Ugly. Ugly. Ooh, ugly. Ooh. Can I slide it back far enough? No, because then I'm in the board. Right, if I look at the assembly and look at the top down, how far back can I go from here to here? Because remember, I can't go further back because one, I'll be under the board, two, there's solder blobs of wires here. Out here, the wires are free. Out here, the wires are free, but in the solder zone, but I can go back another 0.14. So if I shift it back right now another eighth of an inch to start, we can see what happens. So this extrusion is based on what sketch? And this is part of the problem. I was moving extrudes, but not moving their associated sketches. Sketch 20. That's cool. I didn't notice that. It tells me. Extrude 19, sketch 30, right? The little pop-up, sketch 30. And I'm going to grab that sketch when I find it here and drop it all the way down so that they're together again. So that... Excuse me, sorry. That may be an argument for SolidWorks' method of embedding the sketch in the feature so that they move together. That might be an argument in favor of that method. I'm not sure it's a strong argument in favor, it just may be. Edit. I can move it back another eighth of an inch, which gives me 0.25 here, right? And then how bad? Ooh. Ooh. Not great. Can I go another 15th out and make it a little better? Not great. Well, I mean, wait a minute. It also wouldn't be terrible if I just had to whack that corner out. So what if I took this feature, edit, I don't want to go through, I do not want to go through all. What if I went up to a face and went up to that face? Right? It kind of will cut through everything, but it'll stop. That's forgivable. Forgivable is a good word. I mean, it kind of is what it needs to be, right? I gotta have room to feed a connect, to fish a connector up through there. That's not terrible. There's a lot of meat there still as far as the leg is concerned and support for the actual robot. I mean, aesthetically, it kind of sucks, but I mean, it's buried on the inside. Like, are we going to see that? Probably not. So, now, after, I think that is officially, oh, wait a minute, where'd my tunnel here go? Everything's blowing up on me. There's a mirror. Is that the right one? No. Edit. What don't you like? Features to mirror. Oh, that mirror's got to be below. The extrude has to come after. So extrude 16 ended up way at the bottom, right? Mirror's got to come after. If you try to mirror and then move the base extrusion down below it, the mirror has nothing to reference. That makes perfect sense. Like, yes. Now, ladies and gentlemen, an hour and a half, not an hour and 20 minutes, an hour and a half into what was supposed to be the final episode. Now I can start to pretty the thing up. Somewhere way back, I was demonstrating what I was thinking about filleting everything with this. So I'm going to start there, that fillet, edit. I'm going to add it to this side as well. Right? First step to pretty. We've got matching fillets on each side. Now, I'm really just going to grab a fillet tool and start to fillet various edges. We got something going on here. That I noticed, we got to clean that up. So that means this hole has to be below our screw bosses. This hole is the battery hole. Extrude 6. Right? Extrude 6 is sketch 7. I want to grab them both and move them down. It's got to be below. I don't remember which one it said. Let's go all the way to the bottom and see what happens. Anybody break? Anybody? Is anybody red? Nothing's red that actually looks like it's making a difference. Got some sketches that are red. All the features seem to be there. Alright. Start to fillet. And let's start out with a pretty generous fillet. Like an eighth of an inch. I mean, given the scale of things we're looking at, an eighth of an inch is probably pretty big. Okay, it's not very big for that corner, but what if we do an eighth here? What if we did an eighth all the way around this? All right, it immediately breaks. All right, we don't like an eighth all the way around. What if I did an eighth here? That's going to be huge. That's actually not horrible looking. Let's try it. Let's leave it there for now. The other thing to do might be, all right, that's going to break. The other thing to do, like if you find that you're filleting things and rounding things out, and they're breaking like frequently, like I just was, the trick would be to not include as many features in the same fillet so that you can sort of go through and be a little more choosy. So I like the round there. What if I filleted these and sort of, rounded those off? And basically I want to fillet as much as I can. Some stuff is structural that we probably can't. But I'm basically just going to grab everything that I can afford to round. Okay, it doesn't like that one, so we won't grab that edge. Won't grab that edge. Now I could get nuts. Like, what happens if I just click that? It automatically breaks. Fantastic. It automatically breaks. Besides, I probably didn't want to do that anyway because it includes like that hole. But I will in a second go through and fill as much of that too as I can. But that's really this step. Like I tend to call it the beautification step. Do I want to do that particular surface? Maybe not with this diameter because that's going to leave kind of a knife edge of plastic. So probably do want to soften those edges that I just grabbed on the battery box, but probably want to come back with a softer fillet to do that. So what if I do this and this? Will it do that? Okay. And this edge. And this edge. And will you give me that one too? Sure. Awesome. There, and here too. So really, like I said, this is just going through and sort of prettying things up. Now this is admittedly the underside, like, who cares? Who cares? But it's a finishing touch. You know, it makes things look finished, makes them look like they belong the way they are. I'm going to call that there for now. I'm going to come back, but I want to check the assembly to make sure that the fillet there didn't encroach on that circuit board. And it didn't. See, I was worried that this radius might be in the circuit board, which would be bad because that means our circuit board wouldn't fit there anymore. Right? But filleting things like here, that's also strength, right? That's adding more material to these. They're not just at a right angle with stress risers and things. One, stress risers in sharp corners, that's bad. Things break at stress risers. Two, 3D printing. I don't know, again, what orientation this will print in. But if I didn't have a fillet here, and I was 3D printing, which orientation is that? In Z. My layer lines are going like this. That means there's just a layer line with no extra support there. But by filleting it, I sort of build up a pyramid of layer lines and give it some extra support here. It's good. Fillets are good all around. Like, they're good for everybody. So again, back to chassis, and just I'm gonna add what I had. Just keep adding to that list until it breaks. Until it tells me nope. There, okay, like that one. Until it tells me nope. Can I get that? Yeah. Ooh, I actually kind of like how that makes that hook look. Now will I do that? No. Damn. I was hopeful. It'll let me get that one though, probably. Yep. And probably that one. And probably that one. And just going through, grabbing as many of these edges as I can, right? As many as I can. And again, when I have to, I will switch radiuses and go back and catch any edges that I couldn't catch with an 1/8 of an inch. Because some of these are just freaking out because the diameter or the radius is just plain too big. That's what some of these freakouts are. Not all of them. But when it turns red, in some cases it's just because it's just too big. It can't handle, that area can't handle a fillet that size. Like the software doesn't know how to calculate, basically what I'm asking it to do. Okay, like that one. And again, I'll come back. When I go back through this, anything that's still sharp, I'll hit with another radius, a smaller radius. That one. Not sure I like that idea, just because that's already an 1/8 of an inch, and that's now like a knife edge of plastic. So I'm going to get rid of that one on purpose. I don't like that that's a sharp corner back here. Like, I'd like that to be rounded, but we sacrifice sometimes. That one can be, though. Well, I'm going to get rid of the motor. I'm going to get rid of everything to do with the motor. Can I just click to deselect? Yes, cool. I'm going to come back and do the motors kind of separate because it's breaking in a lot of places I don't want it to break. Can I get that? I can get that. Can I get this? Awesome. What about this interface? That would be cool. Damn it. That would have been cool.
I'll come back and try that again. That would have been cool to be able to get. Bottom of this. Bottom of this. What about that interface? I mean, it didn't break it, but it doesn't necessarily like it either. Like my preview disappeared. Can I get the inside of this motor bracket? Yes, I can. There. I guess maybe this edge is okay to do at that size. This edge will probably break it. It does. All right, so let's make it match. Take back what I just said. Make this match this and this there. Good. I'm going to leave those other edges. Well, this one. Can I get that one? Yes, I can. All right. What else? What else is left here? Damn it. Grab as many of these at the same. Okay. I mean, it doesn't take much to select one, see it break, and then just get rid of it. Just say nope. I didn't want to do that. I didn't want to click the whole thing. Get rid of that. I wanted to try that edge. Yeah, okay, it doesn't like it. All right. I mean, I tried it. It broke. I move on. Right. I want to get that edge. Can I get that edge? Not with that. At least not with that radius. So, on the underside, that's probably all I can get. On the upper side, I'm going to go on a limb right now and say I can't get 1/8 of an inch here because of the board. Remember, there's a power board that fits on here. That's why this exists. And putting that there, like I mean, that actually kind of sort of works. That actually kind of sort of works. This one probably doesn't because encroach. Well, yeah, that insert will be exposed a little, but that's okay. That's okay. Okay. What about this one? Nope. Nope. We get rid of that. In which case, I do want to not select any of these. I'll make a smaller radius because I kind of want this whole top surface rounded out, I think. And this is just like, if I mentioned that some of this design stuff was art before, like this is really the art part. Like, what do I want rounded? Right? And you use the preview that they give you of what it's going to look like, and that's probably going to be way too much here for that board to fit. So let's accept it there and check those boards that are underneath. No, they fit. Cool, we're clear. So I can keep going with that plan. I can keep going with that plan and round this guy right out. Cool. So back to the fillet. The one fillet with like 800 features in it now. Select that guy and that guy. Is that every edge in there now? That's every edge in there. That's every edge on the outside of that. That now looks like about all I'm going to get out of the bottom. Can I get these edges of our pyramid? Yes, I can. Yes, I can, and I probably kind of want to. Again, aesthetics. This is pure opinion. Like, this is strictly art. What do I think looks good? Am I right? I mean, probably not. I'm an engineer, right? What do I know about what looks good? It's pure opinion. But that's probably all we're going to get on the underside. What about did I get that? I didn't get that face. Okay, will it do that? Yes, it will. Yes, it will. It'll do that one then, too. Why did my preview disappear? There we go. Just had to noodle on it for a minute and grab that edge, and everybody's nice and round on that boss. Everybody's nice and round there. I missed that. I did get it on this side. I did not even attempt the top of this. Why? Oh, because it broke. That's a good reason. That is a good reason, because it broke. Now, if I'm looking and seeing all the orange lines connected, I don't see a whole lot left. I truly don't see a whole lot left. So let's accept that. Now, generally what I do next is keep going after any of the ones I missed that I would still like to be round, but shrinking the radius. Because usually when things fail, at least on a first pass like that, it's because the radius was just plain too big. So 1/8 of an inch is too big. I mean, I might just cut it in half, 0.625, and go back on some of these edges that I couldn't get and try that. So like here, and did that automatically round that hole? It did, because it followed the existing fillet around. Grab that edge. Okay. What about this? I like what it just did there. Nice, clean all the way through. Can I get that? Yes. Cool. And occasionally you can even hit edges. You can hit edges. You can hit edges you already selected in the previous one too, to sort of blend the things together with the now smaller radius. I did not get that edge, and I did not get that edge, right? So we kind of got to match that over here now. Get the big edges first, right? It wrapped it around again. That's cool. I don't think. Do I want to do this leading edge and do that? I kind of do. I think I kind of do. Yeah. So do the same thing over here. That leading edge already wrapped around, but get this edge here and that edge for a nice round feature. Grab that leading edge and this base there. I don't want to go inside. Remember, motor's got to fit. Well, here it could do it. Here I could do it. No, I can't. It doesn't like it, so I guess I take that back. I was going to say motor's got to fit in here, but this sort of boss is just for that tab, and the tab doesn't actually, cover that whole width. It's fairly thin. I can do this and that. Well, it already propagated to that, so I don't need to actually select that edge. But I can do that inner edge, which means I can do this inner edge. It'll propagate all the way down. It did awesome. I don't want to do the top here, because then we're going to get back into really thin plastic. Like, that's already 1/8 of an inch supporting our motor. I don't want to really go any smaller than that. All right, what else is sharp? What else is sharp? Like, we're sharp here. I'm going to try to... Okay, you don't like that. It already doesn't like what I just did. I kind of want this rounded, though. But it's not going to let me. All right, I guess I'll just suffer with getting the edges that are sort of exposed. Just the exposed ones. I'd really like this edge, but I'm going to take what I can get here. And I guess I could have moved that hole back forward, but the problem with it, if I hadn't solved the minor incursion problem, if it would cut in, and then I tried to fill it, it would also try to fill it the spot that was cut out in a weird way, and it's best to just avoid that. Like, we don't want any of that smoke. So we'll just avoid the issue in the first place, round what we can, live with what we can't, and get on with life. And again, this is I'm just going through grabbing everything I can, right? Everything I can. Can I do this edge? That would be awesome if it would let me do that and sort of give this sort of a rounded bottom look. What about the top? Will it let me do it up top? No, because it's too big because of that lip. Fine. Fine, be that way. What about the outside of it? Well, let me do the outside of it, which is better than nothing, I guess. Which means you should let me do this outside of it, right? No, because of the little tiny lip. What about this? No, because it wants to propagate all along there. What about the inside of it? No. Man, that's somewhat disappointing. I couldn't get this one right, the inside, but I should be able to get this side. Okay. What else? What else? I'm going nuts looking for things to fill it. Like, what else? Oh, I wanted to go after these. Like here, and here. Is there enough material to hit this? There is. Into this. And can I hit these? That would be cool. Awesome. Awesome. It's going to round out that whole... Notice it propagated like all the way around to here. So that's kind of cool. There.
Will it do it to the inside? Yes. Did it propagate? No. Now I got to be careful here. Like I cannot, remember, there's a PCB got to fit in here. I cannot go inside where you see an orange right now. Can't go inside that. So as long as it doesn't do any funny propagation on me and stays outside, I am perfectly cool with that. With that level of sort of propagation. Now what happens if I click, like try to do this? It's going to be too big. Yeah, too big. You can't fillet both sides, so this feature's fairly thin. That's probably even less than 1/8 of an inch. Unless your fillet is less than half, it will complain at you like it just did. So I couldn't fillet the inside of this and the outside of this unless I went with a smaller fillet. I don't want to do that right now with a smaller fillet. Just right now I don't. That's kind of cool, that round right there. Will it let me do the bottom too? No. I like kind of that look, though, if you think about how it'll look from the top. I like that kind of rounded the way that is, so let's try to do that over here. So that'll look kind of cool. And again, this is all preference. This step is all 100% what do you think looks good. Do I want to do that? I mean, I could do that whole face, and it will hit every surface. Now, the question when you do that is you really need to take a good look at everything, like all these openings, and just say, am I happy with that? Oh, don't think I am, actually. I don't think I am. I clicked it by accident. It was a thing that I'm glad it happened because it was worth a look. I want to do that and round that out. And again, as long as I don't encroach, I'm okay. As long as I don't encroach, I'm okay. And the reason I don't think I want to do the face is because I think I want to round the whole inside, like so. Now remember, the only thing that's got to fit through there is wires. And we made it, it's like super big for what we have to pass through this opening. But by doing this first, I'm hoping to get a better rounded look than, where'd my preview go? It's not turning red, but where's my preview? Let's accept, and will it show me my preview? There we go. It's a better rounded look this way. These corners were sharp. If you remember, when I accidentally selected this face, these corners were still sharp. I didn't like that. I wanted them round, and I suspected if I did these first inner edges, it would behave the way I wanted it to. It was a suspicion I had that I didn't voice that I probably should have, given that the entire point of this exercise is to talk through my thought process. I should have probably, talked about my thought process. But I'm going to fillet these inside, and I mean, I might be choking like the limits of what the preview can show me, but it looks like as long as it doesn't turn red, it's actually going to do it. So I'm going to keep operating under that assumption. All right, and the preview pop back in. Cool. All right, let's do the underside. Why not? Here. Propagated everybody all the way around. Good. Here, will it let me? Because those legs get kind of freaky. Okay, it let me. It did it. Actually, it did it all the way around again. Okay. It did it up here too. Did I tell it to do that up there, or did it propagate all the way through that? Huh. All right. I mean, except, and let's see it without all the orange. That looks... We got anything left under here that's sharp? No. Oh, I wanted to try to get those. That's all. That's all. I wanted to try to get these. All right, it got all of that. It even wrapped all the way up to there. Let's try this. I like it. I like it. Is there a surface there? And there's not really. I mean, this. There we go. I already got that on that one. I like that. Anything else? Anything else that sticks out that I missed? I can't really, I don't want to go in here. I probably could. The motor's going to go in there, though, and I honestly, I've got prototypes in front of me. Where did the motor go? The loose one. That's pretty square. I know you can't see that in the small preview, and I'm not going to bother. My camera doesn't do a real good job focusing on the parts that I get. If I get much closer than where my face is, this camera doesn't do an awesome job focusing.
kind of cool with that. Let's accept it again. Take a look without the orange and see if anything sticks out as having been missed. Um, I'm not going to touch these. I'm not going to bother because, frankly, they're going to be buried by the PCB anyway. So I'm not going to bother. Under here, it doesn't look like there's anything super sharp that I missed. I could probably like go with that other fillet that we added. Oh, I was going to try to do that edge. Let's try it. Whoops, that's fillet 3. Edit, add to that, and wrap around there. That's kind of cool. I'm kind of cool with that. Anybody else? I mean, we could do this probably, just to round that out so it's not just a big eyesore that's flat under there. Will, now you let me do this? Yay! 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 So at least we got a little round there. It doesn't match the other fillet. What about this? Nope. I got greedy. Oh well. We'll get rid of it. Yay. Yay. And I couldn't do that one, right? I already tried? Yes. I don't like that. I really, really, really wish I could get that. I may have to go one more size smaller because I want some. I don't like. I'm assuming this thing is probably going to get printed like this, with the bottom up. Which, with the way layer lines are going to lay, I don't like the idea of having square edges on flats here because there's no. A fillet really helps support in 3D printing in the case of layer lines going this direction. It really helps support it. I'm not nuts about the idea of not having them, but I do feel a lot better about those. Those legs look even round now, rounded especially. It's weird with the fillets in there. The legs look stronger than they looked sharp, but with sharp there was way more material. Like triangular, if you think about it, we cut off an awful lot of material by just making them round, but they look stronger. Are they stronger? Probably not. Like that would sort of defy physics if they were actually stronger. But I mean, just from a looks standpoint in a solid model, and again, I don't have this in my hand, it just looks better. So let's look at the whole assembly, the whole thing put together with all the fillets in there. That looks pretty cool. I mean, I don't want to toot my own horn. I'm happy with where we're at. I'm going to end this stream like right here. I'm going to call this complete. The next step for me is I'm going to actually export this guy to a thumb drive probably, or to my Google Drive. Probably a thumb drive because I got to put it on a printer. The printers aren't networked. I got a thumb drive to the printer anyway. But I'm probably going to do it as a step file. I have not ever 3D printed from a step file. And actually, I could do that here. Why don't I mean, because I actually took the time. We have Anycubic Cobra 3s in the lab. I got to figure out how to export. Menu, probably? New. I mean, that's a good exercise. How do I get this part out of here? Appearance, configurations, custom, holes, variables. How do I get this out of you? Rename, move to, copy, update, units, print. Print would be weird. Letter. No, that's actually going to print it. Print. Yeah, print would have been weird. App store. I want to see, how do I export? Because really, the only step left is to export this as a step file and print it. Now, I have never printed a step file. I have always exported an STL, a stereolithography. I flubbed that pronunciation. Stereolithography, because in the old days, and I'm getting ancient, in the old days, STLs were all the slicing software can handle. Nowadays, they can pretty much all handle a step. And a step ultimately is slightly better because you maintain the fidelity in curves and things. They don't turn them into faces.
So I want a step file of this. The question is, how do I get it? Export. Right click on the tab. Cool. Export. I definitely don't want a parasolid. I want a step file. I don't care. So I recommend when designing for 3D printing, I've always recommended this to students. I recommend it to anybody that asks, that bothers. Design your part with the z-axis in mind. That way, when you export the file and put it in your slicer, the print bed is where the print bed is supposed to be because you designed it that way. I recommend that. In this case, I truly have zero idea which way I want to orient this on the print bed. None whatsoever. My next steps are going to be to export this guy, slice it, and look at how I feel the slicer does with putting supports in and things like that. And it's going to be a feel, and I might flip it around a few times to see which one looks better. I can tell you I am leaning towards that it is probably either going to print in sort of this orientation where the print bed is this edge, just because of all of these features would be well supported. I think that would be a good way to go this way. But upside down, looking at things and everything sort of, I mean, realistically, except for these two wire sort of pass-throughs, pretty much all the features are built up from the bottom. So printing it upside down in this orientation kind of looks like it makes the most sense. Like the most sense. I can envision printing it this way. I can envision printing it this way. Plus, having layer lines go this way add to the strength that I was worried about in these front legs. That way, we're not trying to shearing layers apart. We're putting them in tension and compression rather than shear, which would be better because then we're just relying on whatever hold is between layers. So I could see printing it this way. I'm probably going to go with this way. The drawback is this surface is going to be seen. Like this surface here, this plane that's orange, is going to be on the print bed if I print it this way. This surface that's now orange is going to be seen, and it's going to be supported, which means it's going to be kind of ugly. Right? Going to be kind of ugly. If that was on the print bed, that would be like the smoothest surface on this whole part. But it's not going to be on the print bed. So that's the debate I'm going to have. And I'm going to take that offline, and I will figure it out and hopefully have some awesome news for next week's stream about how this thing turned out. I've already got the next revision PCB soldered, put together. It's really, at this point, we're just waiting. I got to order some parts, the carriage bolts. I'm certain I don't have at least one of the threaded insert sizes that's in this design, and I'm certain we don't have the right screws at the right lengths for the sort of wide variety that I grabbed while doing this. So that stuff's got to happen, but I mean, McMaster-Carr deliveries a day, so realistically, all of that stuff can happen this week still, and we can have some fun with assembly. So I'm going to call it there and switch over to the full screen. I'd like to thank everyone for tuning in, and if you're seeing this from the future, hi from the past. Hopefully you found this somewhat useful. If you were entertained at all, I assure you that was purely accidental. But I'm thankful for everyone watching. If you have anything you'd like to see in future streams, since this is fairly wrapped up, anything you'd like to see me walk through, more CAD. I think I may transition at some point into PCB design. I have had some students express an interest and say that they'd like to learn a little bit about that. I'm far from an expert in that, but I can sort of walk through at least the way that I do it. Again, I dread the day an electrical engineer ever looks at those videos, but